I'm Dayna Baumeister. I'm Keystone and co-founder of Biomimicry 3.8. I'm here at the Globe Conference of 2014 to bring the message of learning from nature as a way to find our path to sustainable innovation. Well, as we move forward into the 21st century and trying to navigate our way into understanding what it means to be a sustainable species on this planet, it can seem daunting and scary and terrifying, and we have to rely on human cleverness alone to get us there. But the reality is we're just one of 30 million species, and all of the other species have been here far longer than we have, and we have a lot we can learn from them. They are the epitome of sustainable design, and it serves us best to ask those questions of the natural world of, how do we do this? How do we live here? And that alone, by asking those questions and learning to emulate those answers, is what will really help us navigate forward into the future of being able to survive and live on this planet as one of many species that call this place home. It's a great question. I mean, we are nature. We are not immune to the laws of natural selection, and inevitably we will evolve our strategies over time. The question is whether or not we will evolve them fast enough to save ourselves from extinction. And I like to believe that our cleverness and our ability to actually interpret and look and understand what these other species are doing can help sort of speed up those generations, that we don't need many series of trial and error in order to figure it out. In fact, we can look at the humpback whale and understand how it manages flow and lift to better design wind turbines. We can look at the way that energy flows in beehives and swarms of fish in order how to better understand and manage our information flows. And so there's a lot of things that we can do by using our intellect that we've evolved over the last 200,000 years and our ability to interpret and emulate that I think can help us in the short time that we do have to make a difference. Well, we're seeing a lot of really amazing things happen in lots of different avenues in biomimicry. It's everything from material science. Something as simple as how we glue and stick things together has a huge impact on how we treat those at the end of their life. And of course, we attach things and then they end up having to end up in the landfill when we're done with them. But if we look at things like the gecko and how the gecko sticks to walls, and it can actually peel its toes off of the wall, but it's an incredibly strong attachment, we can change the way that we put things together, and labs around the world are actually developing prototypes of versions of gecko tape. And we can look in places of chemistry and how nature assembles molecules together. And there's incredible innovations in new material properties that allow for hydrophobicity and other functional characteristics from our chemistry that is benign. It's no longer the toxins that we use in our world today, whether it's how we build our building materials, how we create paint, how we produce color in our materials and our fabrics. And every one of those is some example of learning from the natural world that really transforms and flips the way we do things on its head. The term waste is a human construct, and the idea of zero waste is essentially just saying that all nutrients have value and should continue to circulate in the system. And when we look at the natural world, that's true of every ecosystem, especially the mature ecosystems. Something like a temperate rainforest is a classic example of a type 3 ecosystem. And when we look at those systems, we see that the flow of materials and nutrients is a constant upcycling and downcycling and cross-cycling. And one of the reasons that happens is because everybody in the ecosystem is using the same raw ingredients. They're all using carbon and hydrogen and oxygen and nitrogen, and they're not forcing these molecules together in some sort of heat, beat, and treat process, but they're using the energy from the sun. And the laws of thermodynamics teach us that the amount of energy that goes into assembling an object is the same amount of energy that it will take to disassemble that object. And so when we put thousands of watts of energy into putting things together, it becomes very difficult to take them apart and therefore cycle them in this larger system. So when we look to biomimicry or look to nature for advice on how do we manage the flow of materials, those two guidelines alone, use the same common set of building blocks and think really long and hard about the amount of energy that you use to put them together can really help us think differently about how we move things through our systems. The question is not so much of scaling in the sense of taking the identical system and making it larger. Nature simply doesn't do that. But what nature does is take a common system and repeat it many, many, many times at a much smaller scale. So when we need to achieve the scale of addressing many of the global problems that we have today, the key is to identify some of those common design guidelines and allow them to repeat themselves over and over, and to be locally attuned. The lessons for Vancouver are going to be very, very different than the lessons for Durban, South Africa, in terms of how do we cycle our nutrients. The actual solution itself is going to look different, but the design guideline underneath that will be very similar. And that's the only way that we will scale. And we really don't have any choice. But it does ask us to fundamentally change the way we think about how things are assembled. So take a candy wrapper, for example. A candy wrapper has 7 layers. That little thin laminate, it has 7 different layers in there. One is for advertising, and one is for the moisture barrier, and one allows it to tear, and one allows the structure. And we naturally assume that if we want to have these functions, we must add more layers. We're very narrow-minded in that way of thinking. But if we look at something like a beetle has to do exactly the same thing. It has to advertise, it has to maintain moisture, it has to easily open, it has to create some sort of structure, but it does it with just one material. And it changes the structural properties of that material in order to achieve each of those functions. Now, I think that's pretty elegant design, and as we as a society figure out how we have to live here, we have to really fundamentally change the way we design. And it's not about giving up our functions, it's just about thinking very differently about how we achieve those functions so that our materials, our products, our processes can fit in this larger ecosystem of flows of energy. And in doing that, then the scaling issue goes away. But if we insist on doing things exactly the same way, you're not going to find one isolated solution here that will scale and solve that.